And fatal. Oh, that's good.
Yeah.
Oh no!
Oh.
I'll have to open it here. Hang on. Where's my paint? One moment. Find this program. Dude, please. Oh, where is it? There we go. Where is my paint? There is my paint. There we go, should open up now. Okay, so we're continuing with vectors, which is a pretty big chapter. And last time we were talking about, I think, I, J and K, wasn't it? Now, if we just recap what we can do so far with vectors. So, what are the operations we can do on vectors? So let's just say lambda and mu are scalars. And we'll just say or and s are vectors. And I can put the little arrow on the top to show that they're vectors. So, we can add or subtract vectors. We can do this. We can multiply a vector by a number. Or we could even multiply vectors by scalars and add them. Of course, we can add and multiply and divide vectors, scalars. But what we haven't looked at yet is there some way to multiply vectors? Can we multiply two vectors together?
Yes.
Yeah, we can. In fact, there's many different ways to do it, and the way we'll learn about is what's called the dot product. Problem, KJ? Okay, so the dot product, we have two vectors. I'll say or1 equals x1, y1, z1, or 2 equals x2, y2, z2, like that. And I want to multiply the vectors together, and I use this symbol, dot. Now the way they work is like this. You multiply the i's, plus you multiply the y's, plus you multiply the z's, like that. But you notice something interesting has happened here. On the left we have two vectors, but on the right we don't have any vectors anymore. What do we actually have on the right?
Number.
Just number, yeah. So this dot product takes two vectors and gives you a scalar, like this. Okay, so if we can write this down, this is the definition.
So whether the dot product is scalar, that's the definition.
No, I suppose the definition is this formula, and I'm just pointing out it takes two vectors and gives back a scalar.
Where the direction
It's gone. The direction is lost. So any direction that there was before is now gone. Because we lose the I, J and K, because this will just add up to form a single number. This number can't tell us what the I, J and K is. It's lost. So the scalar product, although it's simple, a disadvantage, I guess if you want to think about disadvantages, is that it loses the direction. Now, it's actually the dot product is actually something which is quite useful for vectors, and we can see some of the use now. But just before we continue, let's have a look at a simple example. Yeah, scroll down. Okay. So, here's an example for you to try. For example, we'll do an easy one. I want you to take this vector, 2, 1, 2, and dot it with the vector, let's say, -1, 2, 0. Okay, tell me what scalar you get here. Have a quick peek just for a second. I just want to see how difficult I make to use.
0.
0. Good. Okay. That is 0 then. Let's take another vector. Let's take. Are you all right there?
No, I'm okay.
Okay, you're confusing your teacher.
2,
3,
That's-
5.
no, 2, 1.
You don't know what I'm thinking because you.
Zero.
I know. 2s.
I can read you by 0.
1, 1, 1, and 1, 1, 1.
Oh, about 2, 1, 2, multiply.
Okay, let's just go with Sean was. 2, 1, 2 dot.
2.
Oh.
2, 2, 2. No, it's wrong.
There's
No.
There's no wrong here. It's just an example. So yeah, go try that. Tell me what you got here.
No, not this one.
Okay, we'll do another one after this. What is this one?
No.
No, it's 10.
No.
4, 2, 6, 10. Okay, go on, Sean. Give us another one.
Multiply
All 2,
the first is
S.
6.
S.
The one.
Yeah.
2, 2, 2. In the
N.
2,
no, not 6.
2. Huh? Minus?
But no matter. Three number in the same line.
Oh no. We don't do that. We just want it like this.
Oh.
Yeah. Okay, so you were thinking of something else then. Okay.
Can you? I think so.
Of course. Yeah.
4 components.
0, 0, 1. Yes, of course.
2.
Yeah.
Teacher, I have
2.
a question. What if one
How could you have a question? Go on.
What if one of them doesn't have vector z exactly?
Yeah, that's a problem. They need to be the same size. Otherwise you can't do it. You can do it with 2. Okay, so let's take 2 vectors. So let's say you have something like 3, 4, and you want to dot it with -4, 3. What's that equal to?
0.
That one's 0 then. Okay. And what about let's see which I have there. Yeah, no, we'll go with this one. 5, 12. Okay, here's one for you to try. Actually, let's make this a bit harder. So we'll say example part 1. Let A equal 12 over 13 and 5 over 13, and B equal -5 over 13, 12 over 13. Okay, so calculate A dot B. Yeah, well, hold on. I've got more to come, all right? 2. Calculate A dot A. Part 3. Calculate B dot B. Now I have more, but I just want you to do this to start with. Mark Reynolds, the business teacher, stole my cookies. I trusted him with my cookies. I asked him if he could bring them back to the office. Then when I got back to the office, I couldn't find them. Now I can't find him. Therefore, he ran away with my cookies. What? Is he? Ah, is he still there? Any sign of the cookies?
Maybe he's strong.
Oh wait, I just got a text. That could be him. Maybe it's a picture of the empty box or something. Just a bill. Have we got those calculated?
Yeah.
Quick, shouldn't take that long. Low on juice.
Charge.
Got that? Andrew? Oh, got that? What's the first one?
0.
0. The second one?
1.
And the third one?
1.
Okay. Now, let's just check something. So, I'm going to go back to this question in a moment. But for one moment, let's go to the side here. So what do you think? Is it right to say A dot B equals B dot A? Is that true or false, do you think? Well, just think about it, yeah. If we call A, A1, A2, A3, and B, B1, B2, B3, and this one is B1, B2, B3, and this one is A1, A2, A3. Yeah, when you dot them, you get A1, B1 plus blah, blah, blah. And here you'll get B1A1 plus blah, blah, blah. So, clearly this is true. What about this now? A dot B plus C. Does that equal A dot B plus A dot C?
Yeah.
Yeah, it does. And again, you can show it if you expand it. You can show. So, let's go back here now to this one. So let's say part 4. Vector C equals, let's just pick 2 random numbers. 4 and what's a good number? Lee, what's your favorite number?
9.
Great. Okay. 4 and 9. Find lambda and, don't be evil, find lambda and mu if C equals lambda A plus mu B. So, just so you can have a picture of what's happening, okay? If I just go to the side for a moment. What did I say vector A was?
12 over 13.
And
5 over 13.
both positive. So that would be something like vector A here. And vector B would be something like this.
Minus 5.
Yeah, something like that. Okay. And vector C is something like this. And you know that you could say C is so many A's plus so many B's. In this case, lambda A's and mu B's. Yeah. So my question is, can we find this lambda and this mu? That's what I want you to try and do now. And I'll give you a little hint. The dot product will be helpful.
I could define which one.
I'll even write it down for you. Hint, use dot. Where's my cookies? Huh? Cookies have been transferred? Transferred where? That's what I'm worried about. You got it?
No,
You've given up?
I'm thinking. Just to show me the API.
AB again? Okay.
Is he using Canada?
No. Have we got an answer?
Nearly.
Nearly, okay.
You doubt it.
No, I don't doubt it. You think you got an answer, KJ? Is that a shake of yes or a shake of no?
Huh?
When your head's on the table, I couldn't tell if it was this way or if it was this way. Skateboard today?
Yeah. How can I be careful in this the last one?
I know, it's great, isn't it? And then it was snowing yesterday. So strange. Right, let's have a look. Oh, come on, it shouldn't be. Okay, fine.
But I don't get it. I mean, we don't need to use
Don't we, Lee? Did you use the dot to get the answer?
No.
Are you doing it their way? How many people are actually using the dot to get the answer?
What do you mean by dot? You have to
I only can think about one person to use dot.
Why not do this?
You're all going to be shocked when you see the truth.
Oh, should
Let's
I
do the truth.
stop now?
Maybe. I think you're just digging yourself a bigger hole. I'm going to do it.
No.
I'm serious.
Hold on.
I'm going to find the lambda and mu.
Ignore that I just do it.
Oh, it's 13. I wrote it 3.
Oh man. Right, that's okay. I'm definitely doing it now. So, the trick here, watch the magic. C equals lambda A plus mu B. Now, if I dot both sides by A, what is A dot A? And 1 times lambda? Lambda. And what's B dot A? which is A dot B, which is 0. So what am I left with on the right? Lambda. So lambda is just C dot A. So just take the C and dot it with the A. And you have the lambda. Easy peasy.
Did you do like this one, like, right, and then...
So, 49 dot 12, 13, 5, 13, whatever that is. So that's 48 over 3 plus 45 over 13. And what's that? And that's the same answer. Well, dang. And so, how could I get the mu now? Yeah, dotted with the b. So A dot b is gone, and B dot b is 1, leaving me with just the mu. So mu is C dot b, which is probably going to be the same as you got, but a lot quicker.
Well, what if AA is not 1 or BA is not 0?
That's a good question. That is why I made sure before we did this that I picked the correct A and B so that you have this nice property. So this is one use of dot products. But as Lee has spotted, it's useful when the A and B have this special relationship that A dot B is 0, A dot A equals B dot B equals 1. Let's check which other vectors have this relationship. So here, vector I equals 1, 0, and vector J is 0, 1. Yeah?
Mm-hmm.
What's I dot I?
1.
1. And J dot J?
1.
And then I dot J?
2.
No.
0. Oh, 0.
0. That's the same relationship as the A and B in the last question, isn't it? In the last question, A dot A was 1, B dot B was 1, and A dot B 0. So we like when this happens with vectors, when they have this relationship, because when they have this relationship, it means you can conveniently use the dot to take a vector and to write it as 2 vectors. That's why dot can be useful. There is another thing that makes dot useful, which we'll see in the next lesson, but dot is able to tell you if 2 vectors are 90 degrees. Dot can tell you this. Not only that, but actually dot can be used to tell you what the angle is between them as well. So we notice how we've not actually said what A dot B represents on the graph. You know, if this is A and this is B, what exactly is A dot B on the graph? And that will become a little bit clearer in the next lesson. But for now, I'll just tell you that A dot B, it really has an important relationship with the angle. Yeah. So in other words, a bigger A dot B, maybe that will make the angle bigger or smaller. It has a relationship with the angle. So this, I think, will continue in the next lesson when we look at angles. But for now, we're just practicing dot product. So if you can try some questions on page 74. I think they're all pretty easy. I don't think anything should cause you confusion here. See how well you can do. I believe in you. No, I don't. You're right. How could you tell? Oh. Awkward. I have.